So now we will start the discussion about DevOps project ideas and listed on HEPro.in. In this discussion part, we will explore one of the beginner level projects, Infrastructure as Code ISE with Terraform. In this Infrastructure as Code with Terraform project, you will automate the creation and management of cloud resources instead of manually using cloud consoles. You will write declarative Terraform configuration files to define servers, storage, and networking, ensuring that your infrastructure is consistent, repeatable, and scalable. You will provision resources on cloud providers like AWS, Azure, or GCP, and manage Terraform state files either locally or via a remote backend like Terraform Cloud or S3 with DynamoDB. You will also use Git for version control, allowing you to track changes and collaborate efficiently. By completing this project, you will gain practical skills in automated cloud provisioning, infrastructure versioning, and ISE best practices, which are crucial for modern DevOps and cloud engineering roles. Let us move to the next slide for further discussion. In this project, you will automate cloud infrastructure provisioning using the Terraform, defining servers, networks, and databases with code instead of manually using cloud consoles. You will gain hands-on experience building consistent and scalable environments across AWS, Azure, and GCP. Key tools include Terraform for IAC, cloud platforms for deployment, remote backends like S3 plus DynamoDB for state management, Git for version control, and VS Code or Cloud9 for writing your configuration files. Let us move to the next slide. In this architecture workflow, you start by writing Terraform configurations files.tf that define the cloud resources you want to create. You then run Terraform init to initialize the working directory and download the required providers. Next, Terraform plan lets you preview the changes Terraform will make, ensuring your resources are configured correctly. Finally, Terraform apply provisions the infrastructure on your chosen cloud platform, whether AWS, Azure, or GCP. In this project, you will learn how to leverage Terraform providers to define multi-cloud resources, allowing you to manage and deploy infrastructure consistently across different environments. This hands-on approach teaches you scalable, automated, and repeatable infrastructure deployment. Moving on in the next slide. In this step, you will start by provisioning cloud resources using Terraform for different providers. For AWS, you define a provider, AWS with a region, and then an AWS instance resource specifying the AMI, instance type, and tags. This launches an EC2 instance automatically when you apply the configuration. For Azure, you first define the Azure RM provider, then create a resource group and a virtual network with its address space and a location. By writing these Terraform files, you will learn multi-cloud provisioning, how to configure different providers, and how to deploy resources consistently across different platforms. This hands-on approach ensures you can automate infrastructure setup for both AWS and Azure, building a strong foundation in IAC and cross-cloud deployment. Let us move to the next slide for further discussion. In this step, you will manage Terraform state by storing it remotely, which is essential for team collaboration and avoiding conflicts. By configuring a backend like S3 with DynamoDB for logging, Terraform keeps your state files safe, versioned, and encrypted. The bucket stores the state, the key defines the path, and the DynamoDB table ensures state locking so two team members don't apply changes simultaneously. This setup lets you share state across the team, track infrastructure changes reliably, and work on ISE in a collaborative, controlled environment. Through this, you gain skills in remote backend configuration, state management, and collaborative Terraform workflows. Moving on. In this step, you will create Terraform modules to make your infrastructure reusable and maintainable. Modules act as building blocks, letting you define standard components like VPCs, EC2 instances, or RDS databases once and reuse them across different projects. In your project, you will organize modules in a modules directory with separate folders for each resource type containing main.tf, variables.tf, and outputs.tf. In main.tf, you call these modules with parameters like VPC, CIDR, or instance count. By doing this, you gain skills in modular infrastructure design, scalability, and reusability, making your Terraform code cleaner, easier to maintain, and consistent across multiple environments. Moving on in the discussion. You will implement cost optimization strategies here in Terraform by using variables for configurable resources like instance types and storage. This allows you easily switch to cheaper options like smaller instances or spot instances without changing the code structure. You will also use Terraform Plan to preview infrastructure changes before applying them, ensuring no unintended costs are incurred. Through this, you will gain skills in parameterized configurations, cost-efficient resource management, and tracking changes, making your cloud deployments both flexible and budget conscious. Let us move to the next slide. Next, you will set up your Terraform environment by installing Terraform and verifying the installation. Next, you will configure cloud provider credentials for AWS, Azure, or GCP using access key or authentication blocks. Then you will write Terraform configuration files, main.tf for resources, variables.tf for input variables, and outputs.tf for post-deployment outputs. After that, you will initialize Terraform with Terraform init to download necessary provider plugins. You will then preview changes with Terraform Plan and apply them using Terraform Apply, ensuring that only intended resources are created. Finally, when testing or cleaning up, you will destroy the infrastructure automatically with Terraform Destroy. This workflow teaches end-to-end IAC deployment, resource management, and automated cleanup. Moving on. By completing this project, you will automate infrastructure deployment using Terraform, enabling you to build multi-cloud, reproducible environments efficiently. You will implement state management for team collaboration, develop reusable modules, and drastically reduce human error and deployment time. In real-world scenario, a startup running workloads across AWS, Azure, and GCP can define infrastructure once and deploy it anywhere, reusing VPCs, networks, and compute modules while cutting provisioning time from days to minutes. You will gain hands-on skills in infrastructure as code, multi-cloud provisioning, Terraform modules and variables, remote backend setup, and cloud cost optimization. Moving on further in the discussion. In this project, you will define infrastructure as code using Terraform configuration files, initialize the environment with Terraform init, and apply the configuration to provision resources across AWS, Azure, or GCP. The resources you create, like EC2 instances, virtual machines, and storage buckets, are fully automated and reproducible. You will validate your skills by provisioning multi-cloud resources, managing state via S3 or DynamoDB, developing reusable modules, running Terraform Plan, apply workflows, and applying cost optimization strategies. This ensures you can reliably deploy scalable infrastructure while maintaining control and efficiency. So that is everything that can be explained from the beginner level projects, infrastructure as code, IAC with Terraform. Stay tuned for upcoming projects from HEPro.